Alright, in this video, we're going to talk about the last three applications dealing with the arc length or the area of the sector and all about the good things, okay? So we mentioned about when we talk about the area of a sector, how much pizza I ate. So that will be the formula. And when we talk about the arc length, we reference to how far I walk. All the important thing it is to make sure the central angle theta, we are going to use the radians. So the radians is something we want to do the conversion if you're given the degree, okay? Now, when we're talking about the wheel, the speed, the linear speed, when we're talking about the angular velocity, aka the revolution per minute, we also have a fancy formula that the speed is equal to the radius of the wheel times the angular velocity, the revolution per minute. So based on the cases, we're going to talk three more examples. All right, 11. So we are given two locations. One is the Jacksonville and the other is the Charleston in West Virginia. One is in the Florida, okay? Now remember, we talk about the location, 38 degree, 21 minute on the earth, the globe, okay? So now you know that, real life application. How do I know what formula I'm going to use? Because you read the question talking about the radius of the earth, it is this much. So you kind of have an idea. This is my dear Mother Nature, the globe, right? So somewhere, I'm just to pinpoint this location here, right? So you do know the distance from here on the globe, it will be a curve. So if you think about the center of the earth, right? So you kind of feel like, oh my gosh, I see a arc. And this will be something we want to figure out, the arc length. So therefore, we are going to look for the distance, which we want to figure out the distance between those two cities. So the distance will be my r because the curve, and that is equal to the radius of the earth times the central angle, which is right here. All right, so now because we're dealing with the given information, we know that we want to convert the unit in one. So 38 degree plus 21 minute. So that tells us I'm going to do the conversion. 21 minute, I'm going to times, now remember, 1 degree is equal to 60 minutes. So when we do those conversion, you know that, ooh la la, the minute cancel out, then 21 divided by 60, I will just get a decimal point 35. And what is my unit? Degree. So this tells me this 38 and 21 minutes, that is equal to 38.35 degree. Same thing, I'm going to do a conversion of the 20 minute. So the 20 minute, I'm going to times 1 degree over 60 minute, and minute cancel out. So that gives me it's 1 over 3, aka that will be 0.33 degree. So this tells me this location for my Jacksonville, that is at the 30.33 degree. Now you may say that, so what? We know that given two different locations, that will be the difference, right? The distance, right? Now, when we given the location in the degree, minutes, seconds, you can also see the angle theta, it's also the difference. So the angle theta, that is equal to the 38.35 degree minus 30.33 degree. So I know my central angle, and that is equal to 8.02 degree. Recall the formula we mentioned about when I try to figure out the arc length, I need to use my central angle that is in the radian style. So seeing is believing, I need to do a conversion. So which tells me this is a 8.02 degree. I'm going to times, remember the radian will be pi. So pi It's over 180 degree. So what is it tells us? This tells us the degree cancel out. So 8.02 times pi, then divide by 180. Shall I have a decimal? Of course. So this tells me I will have a decimal. So I'm going to round it up to 2 decimal, 0.14. Now remember, this is the unit in radians. So now if I want to figure out the arc length, the two cities distance, right? So I can see my arc length is equal to r, the radius of the Earth, times the central angle. So what do we know about the radius of the Earth? It is 3,960 miles, and I'm going to times the 0.14, and what you see is what you got. The final answer, you can say that, do I want to give you a whole number? Well, why not? So about 454 miles. So those will be the information we would like to apply. Good. All right. How about number 12? Number 12 said that it takes 12 identical pieces to form a circular track for a pair of toy electric race car. Now in class we mentioned about we are going to translate the English to math, and when there is a picture, the answer is in the picture. So 12 identical tells us everything exactly the same. And when you think about the circular, that tells you a racetrack, right? Looks like that. So pretty much you will still see the center. And then what do you see? You're going to cut it to 12 pieces, right? So something like that, 12 pieces, right? What's it tell us? This tells us the circular is how many degrees? 360 degree, right? Now, each one I'm going to divide by 12 because 12 identical, so each one will be what? How many degrees? So this will be a 30 degree. Very good. Now, immediately, you also know that Maison said that we better keep the angle theta in the radian. So 30 degree is equal to pi over 6. So this tells us we are going to use the radians to do the calculation involving the arc. Now, continue. If the inside arc of each piece is 3.2 inches shorter than the outside arc, what will be the width of the track? Okay. So the width of the track, as you can see here, it is this width, right? In between. All right. So I'm going to redraw a picture to indicate this one. So I have a outside, I have an inside. So pretend this will be my part of my track. Okay. So this is my track. So seeing is believing, because we know for sure it will be an arc. So I'm called the inside arc, it's my S1, and the outside one, it's my S2. So that's good now. And what information we know for sure? We know the central angle, that is equal to pi over 6, 30 degree, okay? So what do we know about that? The width. We want to figure out the track. It's right here. So this green part is what we want to figure out. I'm going to call it X here, okay? Now, we're going to do more translation. What do you mean? Something cool about that. The inside arc of each piece is 3.2 inches shorter than the outside arc. So now we talk about in classroom. When we do those translation, inside arc, as you can see, is S1. It's an equal side. 3.2 inches shorter than the outside arc. So I can translate that will equal to the R2 minus 3.2. So this is give us a piece of very useful information. I'm going to use that. Now back to my picture. What other information I know? So you do know that it will be an arc. What do we know about that? We know two things. In the big arc, So the big R. Okay. What do we know about in this big R? I know that this distance, I can figure it out by the formula. My arc length is equal to my radius times the central angle. Now activate your eagle eye. The big R, my radius will be this measurement. I'm going to label that big R. So that is equal to R times the central angle, which will be pi over 6. This is correct, okay? Now, what do we know about my radius? You know that the radius R, I can isolate that. Once I isolate that, the R is equal to the arc length, the big R, divided by pi over 6. Very good. Can we do housekeeping? Yes. If you housekeeping divide by fraction means times the reciprocal, I can write it as 6 times S2 over pi. Now remember, this is one piece of important information. So far I have 2 pieces very important information. One is right here and one is right here. I'm going to use that somewhere, okay? Moving on. What do we know about the information? I also know, as you can see, the question has a big arc. I also have the small arc. So this will be my small arc. So what do I know about in the small arc? What do we know about that? So the small r still will have the arc length, and that is equal to my radius. I'm going to use the lowercase r times the central angle, okay? Now activate your eagle eye. Because we know that for sure, I can replace my S1 with the given information, which will be is the S2 minus 3.2, okay? And that is equal to, how about my radius of the R? So look at my small r length. My radius is only this part from here to here. That's my lower case r, okay? What can we rewrite? We can say that is equal to the big radius minus the x, the track. Then I'm going to times my central angle pi over 6. Good. So now you can say that, so you know what? I am going to replace the R value with this crazy guy. Yes, indeed. I'm going to replace the R value with this crazy guy. So that gives us, it's my S2 minus 3.2. That is equal to 6 times S2 over pi minus x and times pi over 6. Good. Almost there. What do I do the next step? Housekeeping. We can distribution. So the left side we got nothing, S2 minus 3.2, and that is equal to 6 times S2 over pi times pi over 6 minus x times pi over 6. Aha, here comes our math people housekeeping. Can I do simplify? Yes. Pi and pi cancel out. Good. 6 and 6 cancel out. Good. Okay, what do I left on both sides? Both sides have the S2, so I can cancel out S2. What do I have on both sides? I can drop it. So I have the negative, and negative can drop it. So what do I left? I got 3.2. It's equal to x times pi over 6. Remember, what is our goal? We want to figure out what is my x. So we are going to do the opposite. All right, here we go. Divide by 6, the opposite will be times 6 on both sides. So 6 and 6 cancel out, so 6 times 3.2, that becomes 19.2, and that is equal to x times pi. Remember, our goal is to figure out x equal to what. So what shall we do? We just simply both sides divide by pi on both sides. So pi and pi cancel out. What we see is what we got. So now we got x. It's equal to 19.2 divided by pi. So about 19.2 divided by pi, about 3, right? So that will be about 6 inches. And that will be the answer. Good. And this is what we mentioned about in math, in algebra, right? You may not see anything happening. You have a very good, strong relationship with all those information. But algebra, when we substitute everything inside, we always can find a relationship, and then we do housekeeping. Good. All right. The last one is a good discussion during classroom time. In classroom time, we mentioned about that. What do you want me to get the final answer? Well, I just want to point something out. So the question talking about it is, what will be my final answer in revolution per minute? So in classroom, I do point this out. Given a wheel, you know that's something to do with my circle, and travel, I indicate that tells you it's my speed, right? How fast we go. But your ego, I sees that the wheel is measured in feet, 1.5 feet, so we got this done. But the speed is in miles, so miles and feet are not the same unit, so I need to do a conversion. So therefore, we say that 30 miles per 45 minutes, I'm going to convert that. I need to times. We know that 1 mile is equal to 5,280 feet. So when we times this one, seeing is believing, your miles cancel out. So now number together, you got 30 times 5,280. Then divide by 45, you got a number which will be the 3,520. But what is that unit? My units, what you see is what you got. It is feet per minute. And that's what we say in classroom. Unit, okay? Now, knowing this is my speed. Do we have a formula for my speed? Yes, the speed is equal to the radius of the wheel times the angular velocity, aka the revolution of my tire. How fast it go per minute, right? So therefore, you can say that, well, I already know my speed, which will be the 3,520 feet per minute, equal to the 1.5 feet times the revolution, which will be the angular velocity, the revolution per minute. So therefore, if I want to figure out the W, you know that both sides need to divide by 1.5 feet. Now, this is okay. When we mention about the both sides, you just do math, right? That's what we've been doing, 1.5 feet. And that's the argument coming in. Ms. Ong, what's going on? So the 1.5 feet on both sides, that cancel out. All I left is my W, so that will be my W. Now, number together. Can you do a simplify? 3,520 divided by 1.5. Do you get a simplified number? You do. So you do get the 2,346.66, right? Now, when you do the simplify, the unit, feet and feet cancel out. Therefore, you got what you left. It's the minute left. Now, I mentioned about location. Where's my minute location? It's at my denominator. So that stay in my denominator, okay? Now, back to the wheel. We are measuring in a circle, the unit circle. So the radian is our measurement. So therefore, that tells us the top will be the radian. Good. therefore, I need to convert that to a revolution per minute. And how do we say? I need to bring out the one revolution, one cycle. That is equal to the entire circle. And what do we say in radian? That will be a 2 pi. And the unit, it's a radian. So therefore, you can say that, oh, so the unit radian and radian cancel out. So now my unit, as I see, what do I left? I have a revolution over minute. And that's how we get the unit. Therefore, you can say that, you know what? Number together. This 2,346.66 is number. Divide 2 pi. I can do it. So therefore, this will be our final answer as they request. Revolution per minute. Good. And that's all for today. Be strong and have fun with the application, and that's what we say. Math is everywhere. Thanks. Have a good day.